very beautiful morning to everyone. Yesterday I was reading ARMD, age-related macular degeneration. Then I came across with such terms like hard exudates, then lipofuscin, drusen. So I was thinking about their composition and their location and the differences between these all the things which came to my mind because I was integrating all the knowledge. So first, I decided to look for the compositions of these things like lipofuscin, hard exudates, then drusen and pseudodrusen and vitally formed lesions. Because the things which are made up of the lipoproteins, lipid and proteins, these are hard exudates, lipofuscin, then drusen, pseudodrusen and vitally formed lesions. These are all made up of lipids and the proteins, and these lesions are found in the retina, subretinal space, sub-RP lesions. So lipofuscin, what's the difference between lipofuscin and drusen? So lipofuscin, as I'm just reading that Fundus Autophilosophy book by J.B. Forrester, we have already discussed so much about lipofuscin. It is made up of the lipid, protein, trace elements and little bit of carbohydrate. So it is made up of lipid and protein. And similarly, the drusen's chemical composition is same. The difference is their location. Drusen is extracellular deposition of the lipid lipoproteins, that is outside the RPE, and lipofuscin, it is present intracellularly within the lysosomes in RPE. So lipofuscin is intracellular deposition of the lipids and proteins in the RPE, and drusens, these are present extracellularly, extracellular deposition of the lipids and the proteins. These are also made up of the lipids, proteins and trace elements, carbohydrates. So location, lipofuscin I told, intracellular, lysosomes, RPE, that's their location. And how they appear on the fundus. Actually, lipofuscin directly we cannot say it's intracellular, so directly we cannot say that this is lipofuscin. But because of the accumulation of the lipofuscin, what will happen? There will be cell apoptosis and RPE damage, RPE dystrophy, RPE degeneration we can see. So we see the effect of the lipofuscin on the RPE, not lipofuscin as such. So RPE atrophy will be there, then RPE depigmentation will be there, release of the RPE pigments will be there. So depigmentation mainly, increased pigmentation can be there, and RPE atrophy, underlying choroid will be visible. So these are the changes that we see on the fundus because of the accumulation of the lipofuscin in the retinal pigment epithelial cells. So that is about the lipofuscin, and they have autofluorescence property. They have fluorescence property, and on fundus autofluorescence they are seen as fluorescent material. For example, in age-related macular degeneration, retinal pigmentosa, various rod cone dystrophies, various retinal degenerative conditions. Now drusens. The drusens are actually present between the retinal pigment epithelium and the Bruch's membrane. Now that is not subretinal space. There is a difference between subretinal space and sub-RPE space. Subretinal space is between the neurosensory retina and the retinal pigment epithelium, and sub-RPE space is between the retinal pigment epithelium and the Bruch's membrane of the choroid. So drusens are found between or present between the RPE and Bruch's membrane. That's why the RPE has various internal reflectivity and lumpy bumpy appearance because of the drusen. Now drusens, they can be seen on optical coherence tomography. We cannot see the lipofuscin on the OCT, it's intracellular, but we can see the effect of it on the fundus, and they have fluorescence. Now drusens also, they also have the fluorescence, drusens, and they have hyperreflectivity on the optical coherence tomography, and these are present between the RPE and the Bruch's membrane, and they have got this lumpy bumpy appearance, RPE elevation. Even sometimes these hard drusens, which are smaller, less than 63 micrometer in diameter, the size can be compared with the veins and the vessels of the retina. If they're smaller than that, then these are the small drusens. Large drusens are also called as soft drusens. They can aggregate together, they confluence together, and that can lead to the RPE detachment. and RPE tears. If big RPE detachment, it can lead to the RPE tear. So that is about the drusen. That's the difference between lipofuscin and drusen. Lipofuscin intracellular, drusen extracellular. And then pseudodrusen. What is pseudodrusen? Pseudodrusen actually, it is again made up of lipid and proteins only. Only difference between drusen and pseudodrusen is their location. Otherwise, their composition is same. Composition of the drusen and pseudodrusen is same. Their location is only different. Pseudodrusen is present in the subretinal space between the neurosensory retina and the RPE. That is present above the retinal pigment epithelial layer, while the drusens, these are present below the retinal pigment epithelial cells. So pseudodrusens are present in the subretinal space, that is between the RPE and the neurosensory retina. So that's the difference between drusen and pseudodrusen. Now, hard exudates. I talked about the lipofuscin, then drusen, then pseudodrusen. These are all made up of lipid and proteins. Now, hard exudates. Hard exudates are also made up of the lipid and proteins, precipitation of the lipoproteins, and it is because of the leaky vessels, and the location is outer plexiform layer of the retina. But they can also leak in the subretinal space in case of the retinal telangiectatic conditions. For example, Coats disease, which is seen in first decade of life, especially in males. It is unilateral condition, mid-periphery and peripheral lesions, and there is a lot of exudation. So exudation, it is present in the outer plexiform layer. Also, it is present in the subretinal space because there are so many telangiectatic vessels. Telangiectatic means, tele means end or complete, and angivasal ectasia means dilatation. Means dilated blood vessels are seen in the periphery and mid-periphery of the fundus or retina. So these vessels, they leak, and there are hard exudates, and then there are exudates, that is lipoproteins, in the subretinal space also. It can be serous, it can be lipoproteinous. So that is the another part about the hard exudates, and hard exudates can be stellate shaped or succinate. Succinate means circular, or stellate shaped means star shaped. So star shaped hard exudates are present in neuroretinitis along with the papilloedema, that is the disc edema, and the macular star. It is seen in the neuroretinitis it is seen. And in hypertensive retinopathy also, we can see the stellate configuration of the macula, hard exudate at the macula in stellate configuration, star-shaped configuration, and there can be edema of the disc also, that is in grade 4 hypertensive retinopathy. So stellate shaped hard exudates, differential diagnosis is hypertensive retinopathy and neuroretinitis if it is present with the disc edema. So that was about the hard exudates, which are also made up of what? These are also made up of lipoproteins. So which things or which lesions are made up of the lipoproteins? Lipofuscin, drusen, pseudodrusen, and hard exudates. Now, when hard exudates are present in the subretinal space, especially in the Coats disease, it is seen, and it is one of the most common causes of the RD in young patients, and it is unilateral. So that was about the hard exudates and Coats disease I talked about. Now vitelliform lesions. Now vitelliform lesions, egg vitelliform lesions. Means adult onset is there, and based one disease. Means based one early onset, that is based one, and adult onset vitelliform lesions are there, and there are different stages of it. Subclinical stage, then vitelliform stage, then hypopion, pseudohypopion stage, then vitelloeruptive or scrambled egg appearance, then atrophic stage and fibrovascular stage. These are the stages of the vitelliform lesions, and these are also made up of lipoproteins. Lipoproteinous material gets deposited in the subretinal space, that is between the retina, that is between the neurosensory retina and the retinal pigment epithelial cells. So that is the vitelliform lesion. So I just wanted to talk about these lipoproteinous deposits and their location and the terminologies associated with the lipoproteinous deposits. These are hard exudates, lipofuscin, drusen, pseudodrusen, and vitelliform lesions. You should know their composition is similar, their location is different, and sometimes their configuration is different, the appearance is different, and that's why they are given different terminologies because of their location. So So I'm going to share the pictures of the optical coherence tomography, how they look on the optical coherence tomography, and hard exudates, they give the shadowing effect on the optical coherence tomography. You will see the hyperreflective area. Hyperreflective area means white area. White area, like bright white areas. These are hyperreflective because they reflect. Hyperreflective means they reflect the light more. So that is hyperreflective. And what are the hyperreflective areas? These are Bruch's membrane, the retinal pigment epithelial cell layer. Then you will have external limiting membrane, internal limiting membrane, outer plexiform layer, inner plexiform layer. These are the hyperreflective layers. And cellular layers, that is inner nuclear layer, outer nuclear layer. These are hyperreflective layers. And then these are called as layers on the OCT, and the zones, ellipsoid zone, that is the junction between the inner segment and the outer segment of the photoreceptors. That area is also hyperreflective, and that is called as ellipsoid zone. That is not called as line. Actually, it is called as zone. According to the standard terminology, it is called as zone because it is not the layer of the retina. If it is a layer of retina that is seen as hyperreflective or hyperreflective layer, then it is called as a line. But when it is not a part of the anatomical layer of the retina as such, like these 10 layers, if it is not a part of these 10 layers of the retina, then that hyperreflective line is called as zone or zones. When if it is hyperreflective or hyperreflective, it is called as zone because it is not called as line because it is not the part of these 10 layers of the retina. So I'm going to share these OCT pictures of their location of hard exudates, then drusens, pseudodrusens, and vitelliform lesions. Hope you like this video, and I added certain new things to your knowledge because I really like to integrate all these things. I was thinking about the lipofuscin and drusen. So what's the difference? So my just brain started working. If the lipofuscin intracellular, can we see it on the... No, we cannot see it on the OCT as because I have never seen, but we can see the effect of the accumulation of the lipofuscin. So you should read everything, but you should have your own creativity. You should accumulate certain things and you should integrate certain things that you have learned in your own way, and you can classify them or you can make a chart of them for the better understanding. So I really like to study this way. Once you just go through all the books and all the required chapters, basic knowledge, when you have more than basic knowledge you have when you pass the postgraduate examination. So after that you can start reading and at the same time integrating. For example, if I'm reading the age-related macular degeneration, I don't like just to read the things. If I come across the fundus appearance, suppose fluorescent angiography, then suddenly I should ask what are the stages of the fluorescent angiography and ARMD, what kind of there is hypofluorescence. So what are the types of the staining, pooling, window defects? These are the hyperfluorescent types on the fundus fluorescent angiography. Then indocyanine green angiography, what is the difference? And when the ICGA is done in ARMD, then OCT, then OCTA. Like if we are studying one chapter, we should ask questions to ourselves if at the same time we can cover these chapters in a short time, not in a very short time, but if you are covering one chapter, you should have the collateral knowledge of these. You should integrate the knowledge about these things and terminology and investigations and differential diagnosis also at the same time. So I like to study that way. That is called as integration of the knowledge. If you just read, it's very easy to just simply read the chapter and just close the book. But this is not how you will remember the things because your brain needs exercise. You have to just remember. You just have to strain the brain a little bit, not too much. Strain the brain a little bit and just remember that, yeah, okay, what are the differential diagnoses? Then if we see this, okay, which investigation we should do. For example, if there is a vitreous hemorrhage, I was reading vitreous hemorrhage and I was just thinking, okay, so vitreous hemorrhage is there and proliferative NVE is there. So what to do if there is vitreous hemorrhage and NVE is found on the fundus, and then there are different possibilities, right? The media can be it can be severe vitreous hemorrhage with NVE. It can be moderate VH, and VH grades are also there, stages are also there, severity is there, it's graded. So according to that, what kind of management, either whether you should just wait for that thing, and in which kind of vitreous hemorrhages you should immediately take the patient for the surgery or injections or PRP, when to do all these things. That decision is very important, and you should think in these ways. And literally, there is my one doubt. I had asked VR surgeons in comment section, so I hope I'll get the answer. Once I get the answer, I'll share that my doubt with you. Right now I won't share my doubt here, like what are my questions. Once I get the answers, I'll just share my questions and answers that I get, like confidently. I just want to be confident, so I want the support to my answer if I don't find, because I don't find the answers to my questions and doubts in the books. I have read many books, but I didn't find the right description. Even videos I have seen so many, so there are certain doubts. Once I clear my doubts, then only I'm going to share. Because why to just share the questions here? Nobody is interested in questions. Everybody is interested in listening to answers. So I hope it helps you, and I really like this kind of integration. You also share your creativity, how you integrated your knowledge, and what kind of surgeries you invented, what kind of new charts you have prepared, combining knowledge from different chapters like this. So study this way, you will definitely be benefited. Bye everyone, have a beautiful day ahead. Bye.